Hi, my name is Abhilash and you're watching Code Spectrum. In this lecture, we're going to discuss how to find the volume of the solid generated by revolving the region boundary by this equation y equals to x square and the x-axis on this range -2 up till 3 about the axis. To solve such kind of questions, you need to first draw the diagram of the equation. Okay, we have drawn the diagram, and this is the y-axis, this is the x-axis, and this is the polynomial y equals to x square. And we want to revolve this region boundary, means this equation, about the x-axis and on this range -2 up till 3 on this same axis. So firstly make a diagram for this revolution, and we want to calculate the volume of the solid generated by revolving. See, these are the four volumes regions that we want to calculate. So mainly consider this whole diagram as a cylinder like this, and you know that the volume of a cylinder is equal to, in this diagram the rotation is the pi, this distance is the radii, and also this line is the height of the cylinder. As you can see that the radius of this curvature of this region boundary is in the function of x, which is y equals to x square. It means the radius is increasing with the value of x square at each domain of the x. So we can write r equals to x square, and the h is ranging from -2 up till 3, so we can write it as dx, or we can read it out as height is deviating in the range of x from -2 up till 3. So you can copy the whole formula like this, and now you can replace the value of r with x square and h with dx. Can you solve the integral now? Yes, you can, but if you cannot solve this integral, you may see my previous lectures. There you can understand how you can integrate this integral. And by the way, the answer to this problem is, now let's try out a different example. In this example, we're gonna find out the volume of the curvature, which is created by revolving the region boundary by y equals to x plus 6, and also it is bounded by y equals to x square, the same one. So in such case, we need to figure out the volume of the first term first, which is the conical section. Okay. Then you need to subtract the region bounded by the y equals to x square and the x-axis. So the volume of the required region is given by, we have subtracted the volume bounded by the y equals to x square from the region boundary volume of the y equals to x plus 6, so that we can get the volume with the orange curvature. Let's take another problem. In this problem we have two axes, y-axis and x-axis, and we have the same polynomial y equals to x square, and we need to find the volume of the region bounded by this same polynomial, but this time the axis rotation is different. It is y-axis, not the x-axis. And if you see this rotation sign, it is about the anti-clockwise. So the direction is not mattering here. Just to the sake of explanation, I'm doing this. And there's a range given in the x-axis from 1 to 3. Now consider a cylinder placed in such a way. And if you see, the rotation is about the axis y-axis, so it is a pi. And the radius is varying from 1 to 3, so it is the r is varying. And this line is the height of the cylinder. The radius of the cylinder is the function of y, which is under root of y. So we can write r equals to under root of y, and the height is the range on the y-axis from this point to this point. It should be in the y coordinate. So we can write h equals to d of y. Now you have to find these 2 points. How could you find it? You can place 1 in this equation. 1 square is 1. So the coordinate is 1, 1. Now place 3 in this x square. It should be 9. So the coordinate is 3, 9. If you notice, the y coordinates are 1, 9 and the h is varying from 1, 9. So the required volume of the cylinder formed by this region boundary, which is bounded by y equals to x square, is, after solving this integral, make sure that you get 40 pi as the final answer. Just remember one thing: to solve such kind of problems, assume a cylinder having the rotational axis at the center. Give it a rotation having its pi, and also think about the radius, which radius can be there, and also the function of y or x according to the situation, and also the height, and in which direction the height is ranging. For this case, the height was ranging in the y direction because we were using the radius as the x-axis, so definitely the height would be at y-axis. And that's it. And if you are new to my channel, please subscribe to my channel. I make videos in mathematics, and also you should press the bell icon so that you can be notified every time when I upload a new video. Thanks for watching.